This is third slides for Kriya Hearing. So, we will do some more examples to get familiar with the ideas. So, I am going to work out the formulas, derivation of equations using triads which go anti-clockwise. So, yesterday I did clockwise, but now my vectors will go anti-clockwise and there will be a minus sign will come. Okay. So, we will go through the derivation, you will get more used to the idea of Kriya Hearing. So, I am going to draw the vectors k prime p q. So, they are going anti-clockwise. Now, if you recall, in the last class I was going clockwise, and one point is that my sequence is k prime p q, that is my notation. Okay. So, I just follow that. Now, angles are in front of k prime is alpha, in front of q is beta, in front of p is gamma. No, I made a mistake, other way around. In front of p is beta, in front of q is gamma, k p q. So, alpha beta gamma. Now, here my n cap was q cross p. If you see the definition, it was yesterday's q cross p. So, q cross p was, q cross p will be upward. So, it was n cap was like that. Now, I am going to change my definition here. Okay. So, my n cap for this problem, I am going to use n cap as p cross q, and there is a reason for it which I am going to tell you in a minute. So, p cross q will be again upward. So, my n cap is same direction, it is in fact a z direction. Okay. So, n cap is this way. So, what is my even direction? So, for let us look at for k prime, my k prime, so this is E3. So, my E1 is E3, E1, E2. So, what was E1 was k cross E1 was k cross n by k cross n mod, and k and n are perpendicular to each other. So, this is 1, right. So, k is along k and n cap are perpendicular. So, k cross n is 1, they are unit vectors. So, what is k cross n? K E3 cross downward. So, this will go this way. So, this is my E1 of k prime. Now, with this definition, my k prime is to the right, k prime is to the right, that is my definition. Last time I said, how do I find E1? Just go along the vector, you are right. So, my E1 is always in the same direction, either I go clockwise or counterclockwise. If I make that mistake, then I will be changing my E1, and I want my E1 or U1 component to be the same. So, I will do one example where it will become clear why it should be the same. Is this, I want my U1 to be same whether for triads where it is going clockwise or counterclockwise. I can't have two different U1s for one and another, like my name is my name, whether I go to Calcutta or Bombay. So, if I change my components, then I will be in big trouble with plus minus. So, we do not want to do that, we want to keep E1 in the same direction. So, E1 is go along the vector to the right. What about E2? So, E3 cross E1 is E2, so it is downward. So, E2 is downward for this, and you will find it is the same for everything. So, this will be E1 of P and E1 of Q, downward, E1 of Q. Okay. Now, let us do the dot product of the unit vectors. Okay. So, let us look at E1 of k prime dot E1 of P. Remember, this was what was required in my last derivation. So, when I did, if you look at your notes, you will find that I had E3 dot E1 and E1 dot E1 and E2 dot E2, but E2 dot E2 is always 1. So, that is not a problem, but E1 k prime dot EP, you will get these things. So, in the table we have this E3 dot E1 and E1 dot E1. So, let us look at how to compute E1 k prime dot EP. So, E1 k prime is no sorry now from here you can see that E1 is E1 dot E1 is same as E3 dot E3. Can I say this or no? So, I rotate my E1 by 90 degrees. So, this is 90 degrees, this is 90 degrees. So, if I just left of, well, basically E3 dot, so this is E3. Now if I want to bring it here, so E1p you bring it here, E1p. Now what is the angle between E1p and E1 k prime? This one and this one, this angle, which is same as this angle. They are only offset by 90 degrees, both of them rotate by 90 degrees, these are in a plane. So this is nothing but, this is E3 k prime dot E3p. Okay, they just shifted by 90 degrees because everything is, all E1s are to the right of vector k, so it's straightforward. Okay. Now then that's why it is cos of angle between the two vectors. Well, please remember it is not inner angle, it is outer angle. You see that this is, I have to extend this vector k, this one E3, and my EP is in that direction, correct. This is E3 of p and this is E3 of k prime. So angle is 180 minus gamma. So cos of 180 minus gamma, which is minus cos gamma. You will find exactly the same for counter clockwise as well. So this is unchanged. Yes. Even q, but I am doing oh yeah, you are right, even to the right. So I am sorry, yes, this is a mistake. Yes, even p is going to the right, even q. Thank you. Now let us work out E1 k prime dot E1 no, this is already done. So E3 k prime dot E1p. Okay, I had this kind of stuff. Where did it come? So if you recall, I had k prime dot u of minus p. No, so I had this kind of thing, dot u multiplied by u of minus q. So I need this. So how do I compute this? So E3 is simple, is k prime unit vector. Now E1 I am going to use my formula, which is p cross n unit vector by p cross modulus of p cross n, but this is 1, 90 degrees and it is 1. Now k cross this one, k prime dot p cross n, I will write this as k prime cross p dot n, right. So this cross product and dot product you can change the order. Now what is k prime cross k prime unit vector is a sine angle, sine of angle between the two, and the direction will be again this k prime going to p. So k prime is going to p is upward. So k prime going to p, so my screw will move upward, the right hand screw, and that is in the same direction as n cap. So sine of what? Gamma. Okay. Now if you look at the table, well, the table probably you didn't copy. Yesterday I had minus gamma, minus sine gamma. Now why minus sine was coming? In fact you can see from here, E3 was here, right. E3, the same thing I need to compute E3, and my E3 is here and EP will be in that direction. So E3 cross, can you see this? This one I am drawing. This is my p hat and this is, no, I made a mistake, this is k hat, k prime hat. Everybody is able to see that? Now, what is k prime cross p? Which direction is it? Into the plane, and there, so that is minus n cap. My n cap does not change direction, n cap is the same for both this picture as well as that picture. So, for this one E3 k prime dot E1 p is minus sin gamma. Okay. So, the minus sign will come for all this k prime dot k prime dot u of minus p, k prime dot u of minus q. So, the first term in the convolution that gets a negative sign when I go counterclockwise. So, is that idea clear? Now, you can derive this table. Now, Bharat pointed out that there is asymmetry in the table. So, there is minus, so that is why I started working out. So, this minus sign comes because of this. Sometimes you get, so if you go k prime p in that same direction, I get plus, but if I got p prime cos k prime, then what will happen? So, you can see this, okay, E3 p dot E1 k prime, what is that? There is a minus sign, okay. So, it is going to be p cross k prime dot n, and you can see that this cross product will give a minus sign. Anyway, so this is origin. So, this is some, the table has some nice structure, okay. Now, with this I want to go to the, so table, this table was yesterday's table. Now, we just change it, the minus becomes plus, plus becomes minus, plus this for, so change sign for anti-clockwise. Okay. Now, everything is mechanical. Once you have the formula, you can compute the equations very easily, but we need to keep this in mind. But this one does not change, huh? The second part does not change. Okay. Now, I just go to the equations quickly. So, these are the equations which I did in the last class, this one till here. So, I will just use the red again. Okay. But now, this one, in yesterday's class I had a minus sin beta, the minus here, and this was sin beta, but now it has become plus sin beta. So, this for clockwise, so this for like this, and please remember k prime p q are like that. Okay. So, I just have this sign change, and same, so all this E3 dot E1, E3 dot E1 will give a minus sign. By the way, please keep in mind, I just want to go back once, this one is not changing, huh? U1 remains U1, okay. U1 should not become minus U1, and U2 should not become minus U2. U2 is into the below the plane, right, it is the direction of E2 is downward. Same thing here, if you see there is a minus sign, this is off by a minus sign for clockwise. Okay. Is that clear to everyone? Now, please go through the derivation yourself. Now, I am going to do this example. So, this example and the previous example has only one difference. This was sin x plus y, right. So, in the last example I had sin x plus y, x hat minus y hat. This was what I had last time, but now I am changing this. So, this comes from sin x plus y and I add sin x minus y. So, the number of modes for this problem is more, the more modes. Do you see that or you do not see that? So, last example I had sin x plus y, it has modes 1 1 and minus 1 minus 1. What about this? What are the modes which are required to construct sin x cos y? 4, 1 1 minus 1 minus 1, 1 minus 1 minus 1 1, all 4 are required. Okay. So, this we did in the class. So, so this is what you just need to apply your Fourier series idea, this is not complicated, you just have to do it. So, this we done in the class. So, I am just going to show you the picture. By the way, for me I just copy from my notes. So, I may go a bit fast, but you just have to pick up the idea and work them out. I will give 2 more homework based on this. Okay. So, when you work, you have to work them out, okay, and individually you can discuss, but you must work them out, only then you will learn. And the project will be based on these. If you can't calculate it, then you can't do your project. Okay. So, my modes are, so my table is here, these are my tables. Now, I compute u1, u2 is 0 because it has no z component, it has x component, y component, no z component. So, there is no u2, u2 is into the plane. So, this is my x axis, y axis, so there is no z axis. So, my u2 is 0, only u1 is a 2D field, and the amplitudes are, which I will not work them out. For these, the amplitudes are these, which we did in the last class, is just identical. Please keep in mind that my vector u1 or e1 cap is to the right of vector k. Okay, fine. So, and I gave you these 2 Python codes. We can, it may help you. Game means is there in the Dropbox. Okay, you just look at the Dropbox. So, now let us look at this triangle. So, I have to look at all the possible triads, which will give me evolution of 0 1 mode, 1 0 mode, and 1 1 and minus. So, there are 4 modes. Well, there are overall this in complex conjugate, this in complex conjugate, this in complex conjugate is 1 1, this in complex conjugate. There are 8 modes, but I need to worry about only 4. So, the other one is just complex conjugate of these. So, we do not do it for all 8, we do it for half. Now, I am looking for this evolution of -1 -1 mode, this one. Okay, this is the -1 mode. So, how many combinations of triangle can come? So, I think there was a question, if I have more triads, then I need to just account for all the triads. So, if you see u dot of -1 -1, right hand side will involve convolution. So, let us put a vector u. So, this is going to be k dot of u of minus p. So, I should be able to sum them so that they are 0. So, -1 I have to construct this equal to what? So, how can you construct -1 1? Given these vectors, I have no other vectors. So, what are the options? -1 0 plus 0 of -1. In fact, these are only possibility, I have no other possibility. Okay. So, here I have to have -1 0 and -1 0 -1 and plus flip of these. Okay. But my formula will take care of it, that sin beta minus gamma takes care of both the combination. So, I have only one choice for this one. Is that clear to everyone? For this one I only have only one of them. What about things like 0 1, this one? How many ways can I, how many triads will contribute to this? So, I can erase this one. Now, this is bit of mental jugglery, there is a bit of proof which I have given, but yeah, so this is a slightly tricky part. So, 0 1 you can see this triangle will contribute, this triangle, right, and there is another triangle here, this is independent triangle, no? These two triangles, this triangle and this triangle, both of them contribute to 0 1. So, there are two triangles. So, I have to add the contribution coming from both the triangles, yes or no? So, if I write u dot of 0 1, then it will involve -1 1 coming from here plus 1 0, right. So, if I add these two, I will get 0 1 minus of this, minus of this. So they add together. So k prime is minus p minus q. So if so this becomes 1 1 and this becomes minus 1 0. So that gives you 0 1. This is one triangle, and there is another triangle, which one? Here, coming from here, which will minus of minus 1 0 plus minus of 1 minus 1. So in fact, I do not do this one. I put this one means nonlinear interaction, this plus with a circle. So there is nonlinear interaction between these modes. Is that clear? So I need to get contribution coming from this one and this one and add them. So there will be sine beta minus gamma coming from here and sine beta minus gamma coming from here, but they are two different triangles. It turns out that beta gamma are kind of common, 45 45 90, but it could be different. So you will have two sums, one coming from one triangle sine beta minus gamma and some triangle sine beta prime minus gamma prime. Okay. So these how we have, if a more triad, that is how we take care of it. Is that clear? But you see, this triangle is going clockwise and this triangle is going counterclockwise, and that is where I had to tell you that you need to worry about the sign. This triangle is going clockwise or counterclockwise? Clockwise. This is for 0 minus 1. Huh? Okay. So let us quickly go through this stuff. Minus 1 minus 1, there is only one possibility. 1 minus 1, in fact there is only one possibility, but 0 1 has two possibilities. Okay, I just showed you 1 0 and 0 1 have two possibilities. Okay. Now, so when I write down u1 dot of these vectors, I will get these. So this was like last class, in fact they are zeros, but u1 dot 0 1 has one sign of this, other one sign of this. Now since I am using this sin x cos y combination, my amplitudes of 1 1 and minus 1 1 are connected. Yes or no? So I have sin x cos y. So you can expand this as e to the power I x minus I x by I e to the power I y plus e to the power minus I y, like that. Okay, now there is a relation, one of the, well, there is a minus sign here, sorry. So the relationship between 1 1 mode and minus 1 minus 1 mode, in fact they are all related with plus minus sign, because my structure of the function is this, right? I mean this is obvious. Now this work you have to do, I mean I simply can't do this on this on the board. So this one and this one are related, this one and this one are related. If I do the full thing, it is 0, so all of them are 0. Okay, and as a result what happens? A dot is 0, B dot is 0, C dot is 0. I had more modes, but it turns out for this combination my A, B, C are constants, they do not change with time. Okay. So this is a stationary solution. Okay. I should have shown these pictures. I will try to put the movie for. So this you can see that there are patterns which are constant in time, there are patterns which are oscillating in time. Now yesterday's pattern, A was constant, but B and C were changing in time, oscillating. So that is oscillatory solution. But as soon as I put, in fact the present function has more modes, more triads, but it becomes simpler. The solution is simple. Okay, solution is stationary. Is that clear? Because it does not change with time, so a pattern is time independent. Okay. Now I can derive this from all these formulas. These are nonlinear patterns. Okay, they are not linear patterns. These are only waves which are not changing with time. They interact, they give energy to each other, but they do not change in time. So there is a coupling, there is a in nonlinear interaction. It is not that they are but they do not change with time. Well, we will discuss this energy transfers bit later, but you must learn how to derive these equations. So, this is example 1. Okay. Now, what the example which, well, the homework I would like to give is, so make this sin x plus y be sin x minus y. I should not say a prime. So, presently sin x plus y and sin x minus y have same amplitude or same or minus amplitude. Okay. There I need sin x minus sin x cos y. So, you can see that they must be either same amplitude or off by. Is that clear now? By the way, these trigonometric formulas I memorized them, but I also require you to memorize. How many of you know this expansion of sin x plus y? Just raise your hand, I will not ask you. So, what is it? Sin x cos y plus cos x sin y. Great. So, very good. So, and here this one becomes minus. Okay. So, this is useful. So, if I want sin x cos y, then it should be plus, right? Both of them equal. If I want cos x sin y, then I should have minus sign. So, I would like you to work out this stuff when a and a prime are unequal. Okay, then see what happens. It's a 2D, but there will be something different. Okay, now let us do another example, example 2, which is this, is more complicated. Now, I did not do the whole derivation, but I showed that okay, you can compute the nonlinear term and you can derive evolution for a b c. A dot was minus 4 by 3 b c, b dot was 2 a b minus, and so this it is there in the book. Okay, this was done in chapter 3 of the book. Now, can we do with Cray Herring? Now, by the way, all these are worked out in chapter 9. So, if I do them, what do I get? So, now my modes, what are my modes? Now, this is 3D, so it is not 2D anymore. So, this one gives you what are modes? 101 and is sin x cos z. So, there are 4 combinations plus minus. This one is 0 1 1 and again 4 combinations. This one 1 1 2. Okay. So, there are 8 modes here, 4 modes here and 4 modes are here. So, it's quite a complex set of modes, and in real flows of course there are tons of them. Okay. So, like there are huge numbers, but in real flows some matter more. Some are like Bill Gates and Steve Jobs, and some are small players, and some of the big modes are making the patterns. So, if you understand dynamics of big modes, then you can understand quite a bit. So, it is important to understand these large scale modes. Okay. So, we will see that a bit later. So, I will just make the table. So, I am interested in solving for A dot, B dot, C dot. By the way, they are all 8 modes have certain relations. In fact, they are all connected plus minus signs. So, if I look at the table, so we can construct. Now, this is 112. How will you get? There is only one combination. There is no other 2 ways. 112 can be obtained by 101 and 011 nonlinear interaction. Okay. So, this k equal to p plus q. In fact, you would write as k prime and p and q, but I am just writing as k equal to p plus q. 101 can come in 2 ways, this plus this and this plus this. The proof is there in the book. You will find that in the footnote I have proved this. There are only 2 possibilities given this combination. Okay. And for this again there are 2 possibilities. So, there will be 2 sums. Now, here can I use do they form a plane? Now, these vectors, or can I make a single triad, or there are 2 triads? It is obvious in fact from here. So, in fact, there is these are one triad, this one, but these guys form a different triad. In fact, there are 3 triads, okay, 3 of them. And how do I make this triangle? These are triangle. I hope you can see this fonts. So 1 1 2. So if I add these guys, I should get 0 in a triangle. That's the notation I follow. So they're interacting. These 3 guys are interacting. Is that okay? 1 1 2 minus 1 0 minus 1 and this one. This one is obvious. This is the first one. But there is another one here. So minus 1 0 minus 1 minus 1 0 minus 1 0 1 minus 1 1 minus 1 2. If I add them, I will get 0 or not? I get 0, right? Here, so 0 minus 1 minus 1 minus 1 1 2 1 0 minus 1, I get again 0. So these are the 3 triangles for which are connected with 1 1 2. By the way, this guy minus 1 minus 1 0 minus 1 has only two triangles. Okay, there is a proof for it. Okay, I will not reproduce here, but there is a proof that this mode has only 2 triangles associated with it. There are not 8 triangles, there are only 2 triangles. Similarly, here 2 triangles, and these are the triangles in fact. So we can write down the equation of motion given this. Now, but can I use this more than one triad? So what should be my n cap? N cap, if you recall, was q cross p by this. For the 2D example, just previous one, it turned out that even though they are going clockwise or counterclockwise, I could make n cap along z direction. For 2D I could do it, but can you do this for 2 triangles in 3D? It can't be done. For a single triad we can get n cap which is perpendicular to the plane, but a 2 triad, so you see one triangle, well I can't really draw one triangle here, another triangle which is like this. Well, I mean really they are not triangles, but you can make triangles, you can imagine 2 triangles, and n cap will be totally different for the 2 triangles. So you can't have single n cap for the 2 triads. Then the idea would be, okay, still I want to apply a similar scheme. So choose n cap along for one n cap for all of them. So idea which I propose is choose n cap along z direction, z cap direction. Okay, it still simplifies. It is less work compared to Cartesian geometry. Cray herring is still useful, which is my, if you work it out, then you will find that it is easier. So n cap is z cap. Okay. Now this is a table. So if you use this some maple or SymPy, then you will find that this is what we get. So these are E1. So there are three triangles, no, 3 triangles here, and these are E2s. Now E2 are not minus z cap. Okay, you can see that E2 are all changing. In fact, okay, these E2s are changing. Now U1, U2, you see this is interesting. There is no U1, all of them are only U2 component. Right, U1 is 0 for all these. So is it helical or non-helical? What is helicity? HKK is U1 star U2 imaginary part, right? So it is 0 because U1 is 0. So helicity is 0 for all the modes. Okay. Now this is what I use the code. So I use the code, then I find that the nonlinear term for U1 and U2 are these. Okay. So now this work you have to compute them, and once you do it, then these are the, finally you will get these equations. Okay, and if you do this, then you will get this final equation. Okay, this needs to be automated. Well, I did some automation, but we can use Mathematica, Maple, Python. So this is what we get, exactly same thing with Cartesian. Okay, so I had done this with Cartesian first, then I worked out for Cray Herring. Okay. So, this I am not giving you all the details, but one important point is that n cap is not q cross p anymore. N cap is chosen because there are more than one triad. If it has a single triad, then n cap is fine for even 3D, but if there are more than one triad, then you need n cap to be one direction. And the book has some examples, more examples, please go through them and do it patiently. I mean, you need one full day or maybe several days to absorb this. Okay, thank you.